How's it going? Welcome back to the channel. In today's video, I'm going to be covering a topic that I get asked all the time, and that is high efficient equipment worth the money? Let's talk about it.
This video is brought to you by RLS, Original, Patented, Proven. Diversitech, helping you simplify your work. And by Inficon. Inficon just released their latest refrigerant scale, the Waytec Pro, for all jobs, big or small. It can handle a large capacity up to 275 pounds, or a small charge adapter kit allows you to weigh in the small A3 refrigerant bottles like the R290. So if you're in the market for a nice, good quality refrigerant scale, check out the Waytec Pro.
All right, so let's start things off with talking about what equipment is actually available in the market today. So in the residential market, we have three different types of categories, if you will. You have single stage, two-stage equipment, and then variable speed equipment. Now there's three main things that we look at when we want to figure out which route that we want to go. At least this is what I talk to with my customers. Now we have comfort, we have noise levels, and then we have power consumption. And in my opinion, in that order. So as you go from single stage up to variable speed, you want to look at comfort comes first, right? That's what we're going to notice most if you go up into the higher SEER or more efficient systems. As you go up, they're going to get quieter. And then also power consumption wise, they're going to consume less energy as you get up into that higher SEER rating or into that variable speed equipment. So to boil it down quickly and easily, what is the difference between single stage, dual stage, and variable speed? Obviously, single stage means it's like a light switch, on, off, nothing in between. So if it's a 2-ton unit, it's going to run at 2 tons whenever it runs, and then it shuts off, nothing else. Two-stage equipment, depending on the manufacturer, typically you're going to see first stage is going to run around 60 to 70% of whatever that unit is capable of, and then second stage will run at 100% capacity. So you have a little bit of variance there, and it can adapt somewhat. And then variable speed, you get the full spectrum. It can actually has a full inverter, so it can start off at, let's say, 15%. Again, some manufacturers are different, but it can modulate and step up from 15 all the way up to 100%. Some of them can even go beyond 100% and go into overdrive. So you have a lot of flexibility on the equipment side to be able to modulate. So again, if it's not 95 degrees outside, more than likely whatever unit you have, if it's single stage, it'll be oversized. And the reason is because we size the equipment, and this is a standard, that we size the equipment for basically the hottest day of the year. That way it can keep up when it's the hottest day of the year. But the problem is we don't have the hottest day of the year every single day, so therefore the equipment is going to be oversized, let's say 80% of the time. I'm just kind of throwing a number out there. But that's where the two-stage and the variable speed equipment really shines, because they can adapt a little bit. The two-stage can adapt a little bit, variable speed can adapt a lot to your environment. So now I always say go with the most efficient system. When I say efficient, it's not just power. It's efficient at comfort levels. It's efficient at noise level. So the whole spectrum, not just power consumption. Most people think about efficiency as only power consumption. So going back to two-stage equipment is going to be very helpful. If that's your budget and that's all you can afford, great. Go with the most efficient unit you can afford that your budget allows. Nowadays, there are so many variable speed options out there, budget-friendly options, and we'll get into those a little bit later, that it really makes it a lot easier for folks to get in the door on variable speed technology. So, that being said, if you can afford it, I recommend going to variable speed equipment. Now, going back to comfort levels, what is comfort, right? Normally, most folks, they look at the temperature on their thermostat and they think that is all they need to know. That's not all of the picture, right? We have humidity as well. Humidity is a lot of what we feel. So let's say in the summertime, you keep your thermostat at 72 degrees, but you didn't know your humidity was 55, 60%, or maybe even higher. It's not going to feel that crisp. It's not going to feel that comfortable. But if we were able to pull the humidity down to to say 50%, well, that 72 might feel too cold actually. So you might want to bump it up to 73 or 74. Everyone's different, it just depends. That's just an example. But that's what I hear with my customers. Once we regulate that humidity level in the house and we get it down to where it's supposed to be, they start bumping up their set point because it just feels so much better in the house. Now, going to high efficient equipment alone is not going to control humidity. That's one thing we need to talk about. Now, if you have a thermostat that shows your humidity, it might have the opportunity to overrun the system. What I mean by that is it might let it continue to run and let the temperature drop maybe 1 degree or maybe even 2 degrees because we're trying to knock down that humidity. One thing to know, an air conditioning system is not a dedicated dehumidifier. It doesn't control humidity in the house. It removes humidity as a byproduct, but if you don't have a dedicated dehumidifier and you only have an air conditioner, that's about the best that you're going to be able to do, is overshoot your set point to try to knock down that humidity. So if you're in a very humid climate, like here where I am in Tennessee, it's really good to have a dedicated dehumidifier that's ducted into your system, so that way it's controlling the humidity and then your air conditioner is controlling the temperature in the house. Anyway, I digress. Getting back to the actual equipment itself. The two-stage equipment, the variable speed equipment, they are better at removing humidity. They're not ideal as if you, like I just talked about with a dedicated dehumidifier, but they are better. So that's one thing to note. And the reason they're better is because they're getting more runtime out of the system. In order for an air conditioner to remove humidity, it needs runtime. It needs to run and to squeeze the moisture out of that air. That's one reason. Second reason is because we're able to run at lower speeds, we do get more runtime, but we can also run at lower blower speeds. That indoor fan, if we can slow that down a little bit, we can wring out more moisture out of the air as well. So there's multiple components, multiple things going on here that allows it to be better at removing that humidity. So again, the three main reasons that we're talking about why you would even want to go to something that costs you more money up front is it's going to feel more comfortable in the house. It's going to be quieter, right? Going back to variable speed, the outdoor compressor, the outdoor fan, and the indoor fan typically are all variable speed. So they're going to start up slowly. They're going to ramp down slowly. There's no kicking on and off really loud. So it's a very quiet system. You can have it right outside your bedroom window if that's the situation that you're in, and you're not even going to hear the equipment. So that is a really good option and reason why to go that route as well. And then going back to power consumption. So one thing we deal with in Tennessee, we have a lot of heat pump systems. And on normal single stage equipment, you're going to have an electric heat as your backup heating source, because a conventional single stage heat pump, they start to lose heating capacity a lot once it gets about freezing outside. So once it gets below 40 degrees, your heating capacity starts to drop off, and then it relies on that electric heat as a supplement to be able to heat the house properly. The problem with that is that electric heat cost a lot to operate. So that's why you might be used to very high electric bills in the summertime if you have this type of system. Where the inverter-based equipment shines, because it can tailor its capacity, it can shut fans off, turn them on, and just do different things, it can actually operate, like some manufacturers can operate down to a negative 22 degree outdoor ambient temperature. So that means, depending on your climate, now obviously every region is different, but in Tennessee, we do get cold weather. Randomly, like this past winter, we got down to 5 degrees, but it was only for one day, and then it went back up. So, typically we're gonna be in like probably the 30s or maybe even into the 20s, and that's pretty much it. It doesn't even stay there very long. So what I do for my customers on the variable speed equipment, I'll put in a thermostat that has an outdoor air temperature sensor linked to the thermostat. And then it has a program where you can go in there and say, okay, if it's above, let's say 10 degrees outside, disable the electric heat, don't allow it to come on whatsoever. That's where you're really gonna get your savings, because your thermostat is what controls the system. Even if you have a very high, fancy, high efficient system and your thermostat is not very good and it calls for the electric heat to come on way more than it should, well, that's the weakest link. So that's going to go to the next portion of the different types of equipment that's available. Because when it comes to variable speed, there's actually quite a bit different options. You have 24-volt controlled systems. That's the one I was just talking about with the thermostat, where you can lock it out with your outdoor sensor. Honeywell makes one, Pro One makes one. There's a bunch of different brands that offer that type of control. You have full communicating systems, right? So therefore, it's more proprietary to the brand. Let's say it's a Trane unit. They're going to talk to one another. So it's not a 24-volt conventional thermostat cable. It's more of a communication cable. So the thermostat, the indoor unit, the outdoor unit, they all talk to each other, and that's how it operates. So you're pretty stuck with their proprietary thermostats at that point. And if they have the lockout function or not, I'm not sure. It just depends on what manufacturer you're going with. So if that's the situation for me, I will talk to the customer and I'll say, hey, I like the fact that we don't have any electric heat. We can install it so it's there, but we just won't wire it up. And for whatever reason, if we think we need it in the future, we can go ahead and wire it up. But for now, let's test it out. Let's see how it does. And 9 times out of 10, we don't have electric heat running in Tennessee. The heat pumps, the inverters, they keep up just fine. So yeah, going back to, you have controlled, 24-volt controlled, we have communicating, and we also have what they call VRF. So now we're only talking about variable speed systems, right? Because single stage, 2-stage, pretty straightforward, not a whole lot to talk about there. Variable speed equipment, there is a plethora of options out there. We talked about the 24-volt controlled systems that are typically like a ducted air handler. So those are really good for retrofits. So that way, if you already have a split unit and you want to go to a high efficient unit, you can go with that type of system because you're already going to have pretty much everything in place. Your thermostat cables are already going to be there. The only struggle that we have with that in the field is that sometimes the conductors in the low volt cable, we won't have enough because we might need 1 or 2 more depending on the equipment that we're installing. But there is a workaround around that. If you can't pull a cable, then there is a company called FastStat. So FastStat offers 6 different options. Now, depending on the situation that you're in, basically what it can do is add conductors wirelessly to your system so that way you can still have the functionality that you're looking for. So for an example, this model 7000, they say it's an air conditioner to a heat pump conversion. So that's a thing, right? A lot of people might have straight AC units, but they want to convert to a heat pump, but they only have 2 conductors on that low volt cable going outside. Of course, we are referring to split systems here. Well, what this can do, this has a sender and a receiver. I'll go ahead and open up the box real quick. So you have 2 different ones. You have this one goes to the heat pump outside. This one goes to the indoor unit. Obviously, it has wired connections, so you wire them up at the respective pieces of equipment. And what this will do is these will talk to one another. So that therefore you only need 2 wires, right? And then you could get a full heat pump multi-stage system running off of only the 2 wires that are running outside. So that's fantastic, right? Normally you would have to run a whole new cable. A lot of the times that's just not possible. So being able to have something like these FastStats is pretty remarkable because it makes our job a whole lot easier. Now, another way that we could use the FastStat, let's say a customer wants to install a Wi-Fi based thermostat that needs a common wire to operate properly. And you only have a 4-wire or a 5-wire, whatever the situation is, and you need 1 more wire. Well, normally you wouldn't be able to do it, right? You would have to try to figure out how to steal a wire somehow. Well, they have what's called the common maker. And that's all that this one does, is gives you that extra wire, your common wire, to be able to hook up a Wi-Fi based thermostat and you're good to go. So again, they offer 6 different models that goes from the model 9000 down to the 1000 and then the common maker as well. And they all do different ones. So some of them talk from the indoor unit to the outdoor unit only. Some of them talk to the thermostat to the indoor unit. It has like a small little receiver that can actually go back behind the thermostat in the wall, in the cavity of the wall. So tons of flexibility. I highly recommend you guys checking these guys out because it's going to make your job a lot easier if you're retrofitting a multi-stage equipment, inverter-based equipment that's 24-volt controlled. Keep these on your truck. That way you're stocked, you're ready to go. I'll leave a link down in the description for you. That way you can check these out. And if it's something that you're interested in, you can just go to their website and order some for yourself. But these are super nice to have. All right, so another challenge that we run into when it comes to variable speed or multi-stage, typically the variable speed, but more so I want to touch base on that indoor unit. The indoor units that are ECMs or even X13s, the torque motors. Going from a PSC motor that can typically push through a small return duct size where you would normally have problems before, we're seeing problems now. So whenever you switch over to the ECM motors, they don't like it. They'll slow down, they'll create problems. So that is one thing you really need to look at when we're converting or retrofitting is you need to make sure your static pressure is within range where it needs to be, typically 0.5 inches of water column. But you want to make sure that return duct is large enough, that it's a big, huge hurdle, not necessarily a hurdle, but just something that you want to be aware of whenever you're going through the process of doing your estimate, because if they need to increase that duct, you need to make sure, is it possible? How are you going to do it? Are you needing to add a return maybe, or just increase the size of the one that's already there? But that's definitely something you need to be looking at. And that really goes across the board for all equipment. I mean, just because you can get single stage equipment with ECM motors. So I think it's just a good habit to fall into where every change out that you're going to do an estimate on, if it's possible, go ahead and do a static pressure reading. Look at the return sizes. Make sure everything is adequate for your new system so there's no surprises when you're actually on the install and the guys are there doing the work. So, but that's pretty much it in a nutshell. I mean, we could go on and on and on about the different types. I wanted to talk about the VRF. I think I kind of got veered off a little bit. The last kind of part of this whole equation is VRF systems. Now that stands for variable refrigerant flow. There are 2-pipe systems. There are heat recovery that are 3-pipe systems, but that's typically more in a commercial application. The 3-pipe is where you have let me back up. And a VRF system is where you have one condenser, one outside unit, and one line set coming off of it. So 2 pipes. And then it goes in and it wides or branches off to all the different indoor units. You could have ductless high walls, you could have ceiling cassettes, you could have ducted air handlers, whatever you need for the inside, they have those available, but it's just one line set that goes in, it branches off to all the different indoor units. That's a VRF system. And then they have the VRF heat recovery, which is a 3-pipe, which means that it could be heating and cooling at the same time. Again, that's typically going to be on a commercial application where you might need some air conditioning in the center of the building, but maybe some heating on the perimeter, where there's a lot of glass or whatever the case is. But anyhow, that's a VRF system. Those things are way more in depth than a traditional, let's say, multi-port variable speed. We talked about variable speed, but we didn't actually talk about multi-zone variable speed, because that's when you get into the VRF type of equipment. They also have multi-port. So you have one condenser outside, but then you have, let's say, 3 or even 4 sets of line sets. They go in. So each port or each set of line set will go into one indoor unit. Pipe it. So basically, if it's a 4-pipe system or 4-port system, you're going to have 4 indoor units. That's basically how that works. If you have a 2-port system, you have 2 indoor units, and so on. So you have so many options out there. It can be a little bit overwhelming. So that's why I I think it's a good idea to learn the brand that you typically work with, understand what they have to offer, because it's very helpful when you're in the field, because we run into all different types of situations with our applications, and you want to have the tools, right? You want to know you want to have the ammo to be able to figure out, yep, this works for this works for that. But I feel like I'm kind of going off on a tangent here. Getting back to efficiency, variable speed versus two-stage versus single stage. Again, go with the highest efficient unit you can afford. If you can only afford a single stage unit, then go with the single stage and be happy with that. More than likely, going from what you have to a single stage with currently is basically a 14 SEER. I think they jumped over to SEER 2 ratings now, but 14 SEER 2 is basically single stage. And unless you're dealing with York actually, on their heat pump side, their 14 SEER is a 2-stage, which is pretty crazy. That's a whole nother conversation. But anyway, go with what you can afford. So if you can afford a 2-stage, go for it. If you can afford a variable speed, you should go for it. Because again, it is going to do a much better job at performing and doing what it needs to do. There's going to be a lot of people out there that are more old school mentality that say don't go high efficient because, oh, they're just going to break down, there's more bells and whistles, yada, yada, yada. But that's a very closed-minded way of looking at things, in my opinion, is not the way to see it. The same thing would be, hey, don't go out and buy a vehicle that's over a 2000 model because there's computers and there's too many things that can go wrong. Don't go buy a new vehicle because there's too many bells and whistles. It just doesn't make any sense. We are moving forward in this industry very fast. And if you're a technician, if you're a business owner, if you're an installer, you need to get on board because this is what the future is. Regardless if it's fossil fuels or straight electric, we're not getting into that conversation. Variable speed technology, inverter-based technology is here and it's not going anywhere. And it's going to be the only thing that you're going to see before you know it. So you need to get on board, you need to love it, you need to learn it, because the reality is once you do learn it, you're going to love it. Well, that's going to complete today's video. I really hope you guys got something out of it. Give it a thumbs up if you did. Subscribe to the channel if you haven't already. Let me know what you guys think about this topic. Do you agree with me? Do you disagree? Let me know down in the comment section below. See you guys later.